when you finally understand what GitOps is. So you're finally moving to microservices and adopting DevSecOps. You want to be able to move at the pace of relevance, decouple your teams. You want your stack to be immutable, replicable, and more importantly, you want to be able to instantiate a replica of your entire stack with a push button deployment. We talked in our previous video, DevSecOps, how to compete with baked-in security, about the 3 pillars for modern cyber posture: moving target defense, zero trust, and continuous monitoring with behavior prevention. Now, in that video, we explained the concept of cattle. We explained that you want to be able to kill your containers every 4 hours to go back to immutable state. The more mature you become in DevSecOps, the more you're going to be adopting cattle for your entire platform and infrastructure. This is the concept of infrastructure as code. Infrastructure as code is a critical key component for DevSecOps. It ensures that your production environments don't drift between your development environment, testing, and staging. More importantly, if you're deployed on multiple clouds, sometimes air-gapped and on-premises or at the edge, you want to make sure you have no drift between any of these environments. No human should make changes in production in runtime. Instead, changes should be made in the source code and redeployed by your CI/CD pipeline. That ensures that you have no drift between environments, that your stack is immutable, replicable, automated, with no human in production to reduce your attack surface and make sure that you can disable all these open ports so that insider threat and configuration drifts are minimized. The evolution of infrastructure as code became everything as code, configuration as code, policy as code, and more. That includes everything from your networking, your tests, your configuration changes, and everything else. So what is GitOps? GitOps is the evolution of everything as code. It makes Git the single source of truth of your desired state of your infrastructure, your platform, and applications. Everything is code. It gives you full auditability and compliance by having consistent deployments and even rollback when you have issues. GitOps even streamlines your disaster recovery since you only have to back up your databases and your Git repo. More importantly, your change management is enforced through Git pull or merge request by having multiple set of eyes on code changes to approve those changes. That ensures that not a single person can tamper with your system or potentially make changes that will either break them or introduce vulnerabilities. What's very important when you implement GitOps is to make sure that your CI/CD pipeline does not push to your staging and production environment. When you move to GitOps, instead you pull. What I mean by that is your Kubernetes staging and production cluster will pull every minute from Git, from your desired state branch, to continuously implement that change and make sure that your desired state in Git matches what's running in production and staging. Effectively, you ensure that your CI/CD pipelines do not have the keys to your staging and production clusters. Instead, the production and staging clusters have access to the Git repo. Multiple tools enable you to move to GitOps, but what you're going to find as part of the Cloud Native Computing Foundation landscape are mostly 2 tools with Argo CD with companies like Honus and companies like Weaveworks with Flux. Now let's take a look at this example of a proper way to implement GitOps. As you can see here, your desired state is all code that's stored inside of your Git repo, including your configuration changes by all of your development team. Through the automation process of your CI/CD pipeline, you're going to make sure that you're testing, scanning, static analysis, but also verifying all that infrastructure as code security is performed. And you're going to scan for CVEs and make sure that this can be deployed at scale automatically in your runtime environments. This creates a declarative conversion loop. Effectively, what that means is your runtime environment always matches your desired state in Git. You have no ability to have drifts, between your runtime and your Git repo. If a malicious actor gets access to your production environment, the GitOps stack will enforce the desired state, removing all the changes made manually by the malicious actors. Now, CNCF has 5 principles for GitOps. The first one is that the entire system is described declaratively. The second principle is the fact that the canonical desired system state is versioned in Git. The third pillar is the fact that approved changes can be automatically applied to the system. Software agents ensure the correctness and alert of differences and take action to remediate the drifts. Those actions are performed when the runtime state diverges from state in Git, creating a closed loop system. Again, that ensures that your runtime is never drifting away from your desired state. Any manual changes will be effectively removed from your production environment. Now, let's take a look at a concrete example of a use case where you're a developer here at the top, committing code into the Git repo. First, the code will be built and the artifact will be stored in a container registry. The Kubernetes manifest will be stored into the configuration repository. Then what you can see is the automation process of the CI/CD pipeline to validate the change, do proper security assessments, and then deploy automatically into your development environment. In parallel, what you see as well is a pull request with a second set of eye to review those Kubernetes manifests and changes, the code changes, and the additional requirements to integrate into the application service mesh. And with that manual approval, it's then pushed into your staging and production environment. As you can see, you always need multiple set of eyes to approve the change. Never a single developer can impact your production environment. Now let's take a look at a malicious actor here. Going manually to apply a change using kubectl apply. That change is immediately detected in production by the GitOps capability and is reverted back immediately. Any change that diverges from the desired state is reverted. You can always return to your previous non-state at any time. There you have it. This is why GitOps is a must if you want to move to DevSecOps. You want to be able to remove any manual drift so your entire stack is automated, immutable, replicable, and can be instantiated with a push button deployment. More importantly, you want to continuously pull from Git your desired state and ensure it's always implemented in runtime in production. GitOps also opens the doors to a lot of new cyber capabilities, which will include the ability to look at your source code and compare your runtime to see if there is any drift and be able to map objects running in runtime with a source code repository and be able to proactively propose changes in your source code to fix cyber issues. Many cyber products still have dashboards that still enable you to make changes in production in runtime, drifting away from your desired state. This is not best practice. Ideally, you want to have product that will open a pull request in your Git repo, propose the change in code so a human can review and approve it, and then if it's approved, go through the pipeline process to deploy it in production and not bypassing the pipeline. No more old school change management boards that take months. Now, every change is made in your Git repo. It's all code changes going through the same process of peer review and approval. You define who gets to approve what changes based on the criticality of the change, whether it's one person or two or more. And when they approve the change, the GitOps pipeline will be able to automatically deploy the change in staging and production. Thanks to GitOps, not only you get immutability and replicability, but you also ensure that you reduce your attack surface and remove humans from production environments.